Welcome.
I'm fine. I'm way better.
Glad to hear it.
I'm actually really excited about this one.
Cool. I'm happy. Okay. So I guess let's. I mean, first let's see. So we've gone through all of these things right until now: lambda calculus types, recursive types, type classes, and like some more type classes here, right? Semigroup monoids and so on. But then here we also ended up doing what's it called? Polymorphic functions, right?
Yeah.
And the reason I want to do this here is because I like the kind of mistakes you're making felt like would be. It felt like you'd probably get like fix a lot of the problems you've been having if you understand this part. So I'm not sure.
Okay.
We'll see if that turns out to be true or not. Oh, hey Didi.
Okay.
So yeah, we'll see if how that works out. I was just it wasn't initially in the plan to do it there, but let's see if it helped. So there's some homework, right?
Yeah.
Okay, so yeah,
Yes, there is. Give me one second, please.
Let me open the file. So let's see where. Usually the homework is at the end of the previous lesson, right? So
yeah, I can paste the exercises as well if you.
No, they're here, right? So it's kind of like F1 and then okay.
Yeah.
So no, okay, these are okay. Never mind. So these are not
lower.
homework. These are explanations, and then homeworks is here. Okay, cool. So we have one, define a type for and write a semi. Okay, so first part is about like semigroup and monoids and so on, a couple of instances, and then we get into the polymorphic functions, right?
Okay, so yeah, I do have some questions.
Fire away.
Okay. Fire away. Okay. So do I use data to declare the new type, and is it a Boolean? I don't.
It is.
I don't understand what this is supposed to do entirely, because I know that for semi-groups we have the append function that I should be using, but it kind of slips my mind as how it is supposed to work.
Well, okay, so let me start by saying that this is 100% correct.
Okay.
And then let me try to explain the idea here, basically, right? So when you do something like this, it can feel slightly pointless, right? Because like you're only holding one boolean, so why even like have this and thing? Why not just use booleans, right? Because basically what we're doing here is we're defining, and this is a new type, right? This and with a new constructor right here called and we wrap a boolean, right? So it's kind of like you can think of it as, okay, we have a new thing that we call and we put one boolean inside it, right? And the reason why we do this is because we also want to be able to define or, right? Because so one thing is it is not possible to define two instances for the same class and type combination, right? So like you cannot have two semigroup instances for Boolean, right? You can do either and or, right?
Not both. Yeah,
but not
I
both.
remember you actually told me that last lesson as well, if I recall correct.
So the idea is that's why we need, like, this is kind of like, okay, I want to do this operation over booleans, right? The and, but I want to do it for semigroups rather than doing it manually with this, right?
Yeah.
So if you want a semigroup instance, you have to do this, right? The like wrapping it into a. This is basically kind of like you give it a like one more piece of information to the compiler, right? It's not a boolean, it's an and, right? Which is also sort of a boolean, but you need to wrap it and or unwrap it. And this is exactly right? You have to like unwrap, right? This is unwrapping on the left hand side of the equals, and then you rewrap and then work on the inner values, right? To gain a single value. So yeah, that's totally correct.
No, this one makes sense to me. Okay, so this is I actually forgot to paste the monoid instance.
So what's the property for the monoid instance? Do you remember what the law was?
Yeah, it has to be the neutral value of the
Right, so let me write here for a second, right? So what we want is for any and value, right? That like capital A, and let's call it A, right? we want it to be true that, let's put it here, A and MT is A.
Mm-hmm.
Okay,
Yeah,
so okay.
okay. So for and, it should be true
Exactly.
because it's
Okay,
the
you got
only
it.
way that it. Yeah. It's just a bit of stupidity. Yeah, it makes sense.
Okay, you got it.
Uh,
Wait, what's the problem here?
what have I done?
I have no idea why it doesn't like it. Oh, okay. I think you removed the where by accident here.
Yeah, I did.
Okay, cool. So
And
this is correct.
also there's and here because I.
Oh, was it saying something else? Was it saying all or something?
No, it said.
Oh, okay.
Add, because usually I paste what we did before below the exercise so that it
Wait,
makes
but there
sense to
should
me.
still be an error. Give me a second, because we have an error at the down here. Oh, okay, because
Yeah, they are not.
okay, let me fix these errors.
Okay.
Multi-concat.
I did not understand how to do this one. You said that this one's a bit trickier, but it actually.
Combine one.
Okay.
Okay, I just gave them some dumb implementations such that they work.
But it's still an error.
No, wait. What's the error? Could not match. Okay, I think I forgot one of this, maybe? Or maybe I have one extra. Multi-concat, what? Or, okay, so it's like, it has to be 3, right? So I think it has to be like this. Okay, there we go. Okay, so now if we go here, can you look at the error and figure out what the problem is?
Okay, could not match Boolean with type AND.
Mm-hmm.
Okay, so, but AND is Boolean. Oh, is it like, do I have to,
Mm-hmm.
does it make sense? Oh, wait.
Yep, and then you don't even need these parentheses. You can remove them in this
Yeah,
case.
but I always add them for a structure.
Okay,
It's
cool.
for my head.
I just want to be sure that you know they're not required, and then
Yeah,
if you
yeah.
like them, I don't mind.
I know. You always tell me that I should remove them, but my head just tells me to keep them. Okay, and then this is the exact same thing, except this should be false now. The empty on the monoid instance.
Mm-hmm.
Shouldn't it be the exact?
Mm-hmm. Yep. And then the wrong thing I'd like. So I have a question for you, and also you forgot the where here. But other than that, it's correct. So I have a question for you. When you do your homework, do you also try to put them in a Purescript file and try to compile them, or no?
They are in a Purescript file,
Okay.
but I don't know how to compile them properly.
I think you just need to hit save, and then it should show you the errors.
Yeah, it doesn't give me errors. That's because.
Okay. So maybe let's try at the end of the lesson that maybe you share the screen on Discord and I help you set it up so it works for you. Because I'd like you to actually try compiling them, maybe even try running them and so on. And also you needed a word there. I added it, but you just.
I thought I was on my computer. I'm really sorry.
Okay.
Yeah.
So okay, let's try to remember at the end here, and if I forget to do it today, just ping me some tomorrow or whatever, and we'll spend like 5 minutes figuring it out. But it should be pretty easy to do, right?
Yeah. So for example, if I delete where in my computer and then I save like 10 times, it's still no error.
Okay. Well, we'll look at it at the end and figure it out. Okay.
Okay.
So then we have, this is kind of like a big break here, right? Different exercise. Let's mark it a bit. Okay, so we have this weekday type, and the idea is define an EQ, right?
Yeah.
Okay.
This is, I also have one question here.
Let me do this now. Move it to the left.
Yeah.
Okay, so let's see. One thing that seems to often thrive on newcomers, type constructor and data constructor of data types are separate entities. The end, type end and data constructor end in an and through are different things. Oh yeah. I think I've tried explaining that, but it's still going to be wonky for a while. So let's see. Oh, hey Vince, hello.
We know the difference between the, I think, but what, like I said, because I don't know Haskell, every time I type some Purescript tutorial, there's like 3 of them. You know, like if I search for a tutorial in Java, I get like a million results.
Oh yeah.
But if I go for Purescript, there's nothing that
Yep.
can actually help.
That's unfortunately true. There's a few references. I'll give you, actually remind me to give you some links at the end, because there's like the Purescript book, which I think you're aware of. There's also Jordan Martinez's book. Sorry, not it's also a book, but it's more of a like repository learning resource, which is also very good. So if you want to do some extra reading, I'll give you a few things that I know are good.
Always.
Okay, so let's see. Here the problem is that you're defining an EQ instance for 2 weekdays. But then this thing is also, it's kind of using the EQ instance, right? So I'd be surprised if why doesn't it fail?
Okay. So it should be like recursive in a way, right?
Yeah, I mean, even if it doesn't fail directly here, it still, it will never finish.
It still won't. Okay, yeah.
So what do you think you need to do here in order to get it working?
So basically, I should first say that. Okay, just give me this. I think I should remove this.
Okay.
And then first I say EKB equals.
So okay, pause for a second. So you have this type here, right? The weekday type. So there are no known operations that work on it, right? We have no instances, we have nothing that work on it. So what's the only thing you can do with such a type?
Oh, yeah, wait 1 second. In my example, I was also going, would this be correct? That's what I wanted to ask you. Would this be correct?
Okay, yeah, if you do that, then that can definitely help you. That is one way to write it for sure.
Okay, so then let me paste this, because else wrote from our past examples. So we did this in our past examples. Okay. So if I do, can I call it here?
No, you cannot. No, you cannot. But you can call it on the right-hand side of the equals, right?
Like this?
No, on the right-hand side of the equals, right here, like
after the equals. Yeah,
right?
I mean, I should still use the if then, if I'm right.
I mean, you don't really need it, but you can if it helps.
Okay, so this is how it should work in my head. So if toInt of a.
Okay, again, you don't need parentheses, you just space.
Yeah.
Okay.
Equals toInt of b. Okay. Autocomplete is killing me. Sorry. Okay. Then we get true. And otherwise, or else we get false.
Yep. And then you keep doing this, and it's not wrong, of course, but usually when you have if something then true else false, then you can just do int a equals to int b, and that's the same thing.
Yeah.
Right. Yep. So you can do this. So yeah, this is exactly like, this is a smart way to do it. Another way that would have worked, of course, would be you can just do like all of the
cases. Okay.
Like this, and then you do everything, and then otherwise it's false, right? This is also. Yeah, I'll just comment this. Just so we have it here. But I mean, this is definitely smarter because you write less, right? So that's definitely a good way to do it. And okay, so what about the ORD instance?
Okay. 1 second, please. Oh, okay, so I declared the values. So uh, oh, it's still an error.
So let's see what's the problem here. So we
Unknown type
what?
class.
Oh, okay, so can you figure it out, or do you need help?
No, I don't.
So they're reversed, like it's this.
Ord weekday. Yeah, yeah.
Okay, so that's
Yeah.
the first problem. And then represent. Okay, what's the problem? The following type class member. Okay, so the idea is that ord. Let me see. Did I actually explain that, or did I? Where do we have ord? I don't think it's
We
even
do
in
have.
this. It's in the previous thing, right?
Um,
It's in 4, I think. Isn't it? Or is it in 5?
I'm just gonna. Ord.
No, it's here. It's for comparing, right? It was called compare, and it's a like we called it compare here, right? When we
Yeah.
learned it in part 4. And
Yeah,
then
yeah.
here for the homework, I think I said, well, I probably didn't explain it properly. So, okay, this is kind of like compare, right? So you need to define this function that's called compare, and you have an a,
Yeah.
b, and you need to return either EQ when they're equal, LT when the first one is smaller, or GT when the like the first one is greater than the second one, right?
Okay. Yeah.
But again, like here you did the same error you did for this, right? When you said EQAB is the same as A equals B, and it's again the recursive thing, right? You cannot really do that.
Yeah. Yeah.
So do you think you know how to do this now, considering oops, or do you need some help?
I mean, oh, okay. So I can still do the cases one, where if A equals B. But you're
Well,
saying that
now
I should
actually
put
now you
it.
can use equals, right? Because equals is you have equals from here. So equals is
Mhm.
fine to use.
Is something like this okay?
So no, what you the syntax you're looking for is so let me comment this out so you can see the difference.
The
Is
difference.
this right? So A equals to B and then equals EQ. This is how you do it, right? You need to do this sort of like this the
Yeah, okay, yeah,
cases,
the
right?
segmentation.
Mm-hmm. And then
Yeah.
you have other like otherwise, because the problem is you cannot really say what happens in other cases here, right? Because you cannot use smaller and greater because that's literally what you are defining now, right? So you cannot
Yeah, that's
reuse
true
this and
actually.
this. So you kind of need an otherwise here, and but then what do you do here?
I mean, can I call the toInt again?
Yep.
So
That's
I would
probably
have
going to be the
to
easiest to do.
do toInt of A
Okay.
is bigger than is greater than toInt of B.
Okay.
Then we get greater than. I put capital B for some reason.
I wonder if you can do that here in this. I think you can. I think in this case you can do it here, like so. So you don't need the otherwise yet. I think that's okay. And then?
And then otherwise it's lower than.
Okay.
Right? I forgot this. Yeah.
So let's see if I think this works. Another way you can do this is, and I'll write it here, is you could literally just do compare to int A with to int B. Here, right? You can do equals, right? Instead of all of this, you can do, right? Because like there is an ord instance for integers. You just compare the numbers, right? Yes. Which is kind of, you did this kind of here and here. But you could have not, you didn't need to use this, right? But this is also correct. It's totally fine if you write it like this.
Okay.
This is the okay. I can go from weekday to int, so then I can just use the int instance.
Yes.
Okay.
And the bounded instance. Okay. Well, is it like the bounded instance is the one with the top and the bottom, right?
Yeah, I think so.
So it should be like bounded weekday. Wait, there's no.
think that's the problem. And then let's see, top. All right, because these are also with
It's
like
top
this.
prime.
Yeah. Exactly.
Yeah. They.
Yeah, I think this is correct. This is the right implementation. So, good job.
Okay.
Okay, so we get to the cool part now.
I think the last one, the last function that you gave me was just meant to.
This too?
Or
what do you mean?
Oh
Like,
no, I was talking about the. No, I couldn't do the last two. Like
okay.
those were.
Cool, no problem. We'll do that together.
Okay, I'm sorry, but
don't
there's
be
no
sorry.
way I can actually do.
Don't be sorry.
So.
Okay, so let's see. So you have A to B to C, C to D, A to B, and then an A. Okay, they're correctly named. What did you... Okay, cool. You remove the space. Okay, so you're saying that we can get a B from calling A to B on A, correct?
Okay.
Can get a C
Yeah.
from using that B and that A here. Okay, and then you can get a D from calling C to D, C, and then you can get a D. Cool. I mean, you know, I don't even need to read it because, well, you kind of... Actually, this is my bad.
Okay.
I kind of... okay, so in Haskell, you don't have to write this. In Haskell, you can just use type variables without introducing them with a for all, right? And this is implied. So that's why I forgot. Sorry. Right. So you can just write the second one, like paste it if you got it. Okay. So let's see if it compiles.
Actually, no problem because my computer doesn't give me any errors anyway. So
A to B to C D. Well, do you see the problem here?
Wait. So it's okay. Can I take them step by step? So it's A to B to C
Sure.
to D. So the first one is correct. Then I have an A to B, which is also correct. Fine.
Okay, I won't. This is just a typo. You forgot a 2 between C and D here. Like it's a spelling error.
Okay, I'll fix it now.
Okay. So A to B, A to C, yeah. So the cool thing about these sort of functions is that there's only one way to implement them correctly. So if it compiles, it's correct. So we don't even need to read it carefully. Okay, let me do the for all while you grab the like copy paste the thing. Okay, so now you can paste it. Okay, you forgot the equals here, and then what's the problem? Oh, okay. So do you see the problem here?
So I have. Should A and B be at the end of
No. Okay, so let's look for things. So we have an A and a B, so these are correct, and we have an A to B function, and then we have a function which takes two B's and returns a C, right?
Yeah. So you told me that I should get one B from the
input.
Yeah, and one from the A to B.
But then, like here, the warning here is saying that you are redefining this B here, right?
So it should be like a B prime or something?
Yep, that works. Okay, so then you get rid of the warning, but then like you're not even using B prime because you're also doing A to B A here, which is the same thing as this.
So I should just say B prime B.
Yep. Either that or you just remove this part because you don't need it, right? But it's better if you just put B prime there. Yep.
Oh.
And then this is correct. Cool.
Okay. So actually, I was actually the homework was not that bad today.
Actually, this sort of thing is so important to get into the mood and the style of looking at the types and then kind of, okay, what do I have? What can I do with what I have? So this is very much what most of us do when we write actual real code in Haskell and Purescript. Or at least a big part of what we do. Okay, so these were a few examples here, and then these were the complicated problems. So let me try to start it off and like try to explain my thought process for a second. But then maybe if you think you got it earlier, like before I finish, just type Lego. Yep, type Lego, type Tetris, whatever. I think Lego's better. Not sure why we call it Tetris. Lego makes more sense. Right. So we have 1, 2, 3 A's, right? So we can just say A1, A2, and A3, right? And then equals. Correct? Is it clear so far?
Yeah.
Okay.
Yeah.
So we have to return an A, right?
Yes.
In a way such that we hopefully use all of our A's. Okay, so the question is, do you know what operations give, like, what does it mean to have semigroup here?
It means I can apply the append function?
Yep.
Or am I wrong?
Yep, exactly. So what does the append function do?
Do I call it?
Well, okay, let me give you a small tip. There is, like, this function is the same thing as append. So, for example, instead of saying append A, B, you can just say A, B, like this, right?
Mm-hmm. Yeah, okay.
Just do that because it's easier.
Is this supposed to be like A1, A2, and A3?
Yep,
like
exactly. That's all.
That was all?
Yep.
It felt like it's too simple to be this.
So that's the whole idea, right? So when you look at, for example, if you look at this, right?
Yeah.
This means like there is no type class here, right? Here in between the dot and the parameters. So that means that you know nothing about A, B, or C. So the only thing you can do is pass it to a function and get the result, right? That's literally, and then or return it. That's all you can do with anything from here. But when you see like something like this here, and these are called constraints. It's a bit weird that they're called constraints because like they're not really constraining. They're actually allowing you to use more operations on this type, right? It's kind of reversed in a way, right? Because like it's not really giving you less options, it's giving you more options on what you can do with an A, right? Because without this, you cannot do, like, without this here, what can you do? Do you know?
Yeah. I can okay. Right, so for you're asking me what can I do with this notation or what?
So what kind of function could you write with this, right? And it's a bit of a trick question because in this case you cannot use all of the A's, right? If you have this kind of function, you kind of have to pick one of them and return it. You can return A1, you can return A2, or you can return A3, right? But you cannot do this, right? Like you can do this or this or this. That's all you can do.
Yeah.
Like there's like 3 possible functions, but there's nothing else you can do. But then if we...
I remember this. Yeah. You told me this last time as well. I'm sorry, I had like a brain fart now, but I know exactly what you're talking about. I did not forget this.
Cool.
Yeah.
Right, so, but if we add this, then look here, we can do this thing, right? We can also do this thing. That's also okay. Or this, or 2 and 3, or whatever, right? Of course, the one that makes most sense is this, because we use everything. But we can also just combine 2 of them, or these 2, or those 2. So like this gives us so many more options of what we can do here. And of course, even if we have semigroup here, we can still just return A1. Right? It would be a surprise if that was the case, because you don't like it. This would be a weird function, because why does it require a semigroup if it just returns the first value, right? So usually when you see a function, you kind of assume that all the inputs are used most of the time. Sometimes, like for example, there are very few functions where they explicitly disregard one of the inputs. But you usually expect it to use all the inputs, and usually expect that the constraints are used for something, right? So, for example, when I see this, I automatically know this is what it does, right? And that's what I'm hoping for you to be able to do at some point, right? To kind of, just by looking at the type definition, you kind of have at least a broad idea of what it does without looking at the implementation. Okay, so do you think you can think about this?
That's what I was thinking about. That's what why I wasn't really paying attention to your question. Okay, so I'm still gonna use this.
That's fine.
Okay, let me get them so step by step, right?
Yep.
So I know that the input is a value b, right?
No, that's not an input. It's okay. This is a constraint. Okay.
Yeah. I know that the input is a actually.
Okay.
So let's say a1 and a2.
Okay.
And then I get the function which you called f. So
you can call it a to b if you want. if it makes it easier for
yeah,
you.
yeah, that actually would
You're,
make
you're
a lot
used to
more
that,
sense.
so do that instead. Okay, let's remove this and see what you can
Okay.
do.
And it returns a value v. So
You can
okay,
even use the let syntax that you've been using in the previous ones if you want. That might help you.
the what?
The let syntax, like this let in, like you used here on top.
Okay.
If you
So
think that helps you, can use that. I was just giving a suggestion.
okay, let's try. Yeah. So yeah, no, actually, I mean, well, b would be equal to a to b of a,
Okay.
right?
Wait, what
But
you don't? What's a? Because you have a1 or a2. You don't have any a.
yeah, that's correct.
I mean,
Okay.
both are a. So which one do you pick?
I don't think I. Okay, so
Okay.
wait, this would make the most sense to me.
Okay. Okay. And now what? It's correct so far, by the way.
And b.
Okay.
So,
But then you don't use b prime, and which means you don't use a2, right? This is you can delete this line and the program still works. This doesn't do anything.
Yeah.
So okay, so we're using this, right?
Yeah, but I'm not using the second one.
You're kind of not using the second one, but there's one more thing you're not using.
I'm not using the b prime, but
No, one more thing. There's one more thing that you're not using.
A to b, a to.
Look at the left of the arrows. the semi group, right? You're not using the semi group, but it's there.
Okay. So how do I use it exactly?
So
Okay.
what does it mean to have a semi group B? What can you do then?
So I can append them.
Okay.
Right?
So does that fix your problem? It's a trick question.
It does not fix my problem, but I can.
Wait, what can you append?
B and B prime, right?
Okay. And
so do I go to B and go? I honestly, this is what it should say, but I don't know where I put it.
Just here instead, in the in.
Because this is the result of the.
And of course, like you can also say something like result equals b and b prime, and then return result if you prefer. Right, that's also fine. It's just a matter of taste here more than anything. Both work just fine. I would probably just do in B and actually I would probably call it B1 and B2 because kind of like to somehow connect them to A1 and A2, and I would probably do B1 and B2 like this, right? I also want to make sure that while I think it's a good idea to use this syntax because it will make it clear how this works, I want to kind of make sure that you understand that it is exactly the same thing. I'm just going to copy these two parts. It's exactly the same as saying A to B A1 combined with A to B A2.
Yeah.
Right? It's wait, and I need to rename, like to give it a slightly different name. Right? Because like basically you can just replace like B1 with its like right hand side here, replace this with this, right? And then you have exactly this. And you don't even need it anyway.
For some reason it's easier to read the one that you wrote.
It's easier after it's written, but as you write it, it's probably easier to write this step by step.
Exactly. Yeah.
Right?
Yeah.
So again, you can even do that, right? You can write it this step by step, and then you can rewrite it like this if it's easier for you. Like do whatever feels more natural. Like there's no wrong answer here. Okay, cool. Well, let's go to her kind of types then.